We have seen the work energy theorem, and we saw that the change in the kinetic energy of a system is equal to the work done by a force F in moving this system from position XA to position XB. However, we haven't quite defined the various terms in this equation. For example, what is kinetic energy? What is work? What is energy in general? So in this video, I'll just attempt to kind of explain conceptually the meaning of this equation. So first of all, energy. Let's define energy, right? Energy is defined as the ability of a system, so the ability of a system to do work. All right? So when energy is transferred from a form to another, then work must be done. All right? So this is one of the fundamental principles and concepts in energetics. So for example, right, e.g. you have a block and it's on a flat surface, right? It's on a flat surface and you're just pushing it with a force F. What you're doing here is, okay, so you're pushing the block, and when you're pushing the block, what are you doing? You're transferring energy, all right? By having contact with the block and applying a force F, by applying a force F, and because I apply this force, what you're doing, you're doing work on the system, all right? So you're transferring energy from your body to the block in the form of, as we'll see later, in the form of a special type of energy called kinetic energy. In the form of kinetic energy, which we will see very soon. Kinetic energy. And how do you do this? By doing work on the block. Doing work on the block. Okay? So you're pushing the block, you're doing work on it by applying a force, and this force transfers energy from you to the block in the form of kinetic energy. So work, let's now define work. Work is done when energy is transferred. Alright, so energy can move from one form to the other, you can transfer it from a system to another, and that is when work is being done. Finally, let's look at kinetic energy, which is the final kind of main concept in the work energy theorem. So kinetic energy. What is kinetic energy? It's a form of energy attributed to a system due to its motion. Alright, so it's the energy, I guess, encapsulated in the movement of an object or a system in general. So returning to the case of our block right here, so initially the block, so in it, what is the kinetic energy of the block? It's not moving, alright? So since kinetic energy is attributed to a system due to its motion here, the kinetic energy is zero, right? Instead, after you have applied the force, what is the kinetic energy? Well, it's definitely something, alright? Call it a constant. Because why? You applied work. Okay, you did work on the block, and this coincides with the work energy theorem because we saw that work is done by a force F and causes a change in kinetic energy. Alright, so to summarize, what can we say? We can say that change in kinetic energy and work done by a force are equivalent. If you have a change in kinetic energy, that means that work is being done on the particle or the system. If you're doing work on the particle or the system, then you have a change in kinetic energy. So hopefully that cleared a bit what the work energy theorem says, and in the next video we'll look at generalizing this theorem in higher dimensions.